Good evening, everyone, and welcome to this fourth lecture. Today will be the final lecture of the plain C++ lectures, and thus we will implement the interactive console where we can play finally against the AI. So at the end of the day, we will end up with a fully functional chess game where we can play player against player, player versus AI, and so on a certain skill level. So without further ado, let's head right into it. When we take a quick look at our current project progress, we can see that we already advanced to the C++ console program and actually the last lesson of the plain C++ part. So let's do a quick recap. What exactly is Stockfish doing and what did we do the last time? What is the fan extraction about? And then move on to the actual console game interaction where I will show you how we can implement that into code. As you can also see, this will be the last session before we move over to Unreal Engine 5 and implement this whole part we will now do in 2D using ASCII art on a completely fully custom built 3D environment where we can then play chess by just simply clicking with a mouse button. All right, before we go there, let's do the quick recap first. Recap what we did so far. Let's start with the relevant files and functions. At the second lecture, we already had a look at a chess AI handler where we found out how Stockfish is giving us the information we need to build the whole project. So to tell you what it does in less than 3 sentences, we can simply send a command to Stockfish and it will give us an answer. When we then use this answer to extract our interesting parts, such as the best move, all allowed moves, the board, and the fence string, so the updated fence string it gives us back, we can use that to change our board state and also to determine which moves are possible and what would be the best move from the current position. The fan parser, which we built the last time together, was all about how can we extract the values from the fan string, such as how does the board look like, who's playing, so whose turn is it currently, is it white or black, what are the castling rights, do we have an en passant, and so on. And today we will finally encapsulate it all in a final game where you can just enter your name, some difficulty, and so on, and play against this Stockfish yourself or against a mate. You can choose whatever you like. And yeah, that will be the lecture of today. And as you can see, we then finally finished the relevant files and function for this plain C++ lectures. All right, let's head over to the program. You might wonder, how can you start implementing a game now? And the answer is fairly simple, because you will always have some kind of loop. I just provided some for you here, so you can have a look at the internal loop here. And the internal loop and the standard loop are two different things. The internal loop will always happen without an input from the user. The standard loop includes the input from a user. So we have to distinguish here between two kind of games. So one game is the console game where only something happens when you provide an input. And the other games, for example, if you are located in an open world and bird is flying by and so on, this will all happen in the internal loop and you don't have to press any button to do so. And you can also die, for example, if you get hit by a bullet or something like this. So that will all happen in the internal loop and you don't have to process an input. But even in the open world, you will be able to change the state of the world once you process an input. So for example, you move forward and then the positioner from your character will get updated. It will be checked, as always, if you have a collision, if you have to die, or if you got hit by something. And then it will be rendered for you so you can actually see what happened internally. And this whole process is always the same. in 3D, in 2D, it doesn't matter. For our game though, it looks a little bit different. As you can see, I already provided it for you here, but I still want you to think a little bit, and please pause the video here and just think how you would implement our chess game to be working. I will move on now with the game start. So you will always have something that triggers the start of your game, and then you want to start the initialization. So for example, you want to have something like the player name, you want to have the difficulty rate he's playing on, and so on. And afterwards, as you can see, we're already heading right into our game loop. And this is our whole game loop. It starts with the next move, which is an input from the user. And then we have to check whether this input was valid or not. If it was valid, we move on and update the board state. If it was not valid, we will ask him again to provide us an input and we'll tell him what was wrong. So we will only allow him to move on in this graph once he provides a valid input for us. If he does so, we will update the board state. So we will request Stockfish to give us the new board state and then check whether we have a draw or a game over. So if a draw is able to be offered or if we are currently in checkmate. And if this is the case, we simply end the game. You might always have something like a end initialization, so some variables which get unset or something like this, but you will always have something like a game over state. So if no draw or game over is there, we simply move on and go back to the next move and wait for the input, this time from the other player. So maybe it's we started with white and then the black player is the one whose turn it is currently. And then we will process the whole part again. So once he provides a valid input, he will update the board state. We will check whether we have a draw or a game over. And if this is not the case, we will move on and the white player can provide his next move to us. So that's all about the game loop. Let's see how it looks in code. Welcome back into the console chess CPP code. And I just want to show you what exactly is located in there. So first of all, we're using namespace std here once more, so we don't have to always write something like std double point cout or something like this. So we can just simply use cout and that's working for us. Then we have some colors here, which are simply strings, which have a specific kind of type, which we can use to set our colors. And here is our input string, which is currently empty because we have no user input. Then we have the chess AI handler, which will handle our requests towards Stockfish. Then we have the skill level, which is currently set to 5. We will have the player color current player. And I think I have to explain what this player color is, but you will see it in a second. And then we have a map which maps the player color to a player info, which is called player details. You can also see we have a function get valid skill level here, which is not implemented yet. And we also have no player details at the moment. So this is what it looks like for you. We also have the get a valid move. This works already, so you can actually input something and it will always check whether it is a legal move or not. But we still miss on the get next move, which is not implemented yet. So what we will start first, once I open the already finished program, is have a look at how the game loop is implemented, because it's also not in there. But what you can already see is that a game loop always consists of a while true loop, which you can only break in certain conditions. And with that being said, let's move over to the finished program. Back at consolechess.cpp, but this time in the already finished code, I want to show you exactly what I meant. So the first question which might arise is, what is a player color? And we can simply check that by hovering over it, holding down the control key, as you can see, and using the left click to open it up. And we will be led to the console chess.h file, which is our header file for the console chess. And you can see the player color is an enum. So what is an enum about? And why do we use it? So the easiest way, it's not exactly like this, but you can think of it like an integer. So white is a 0 now and black equals a 1. But instead of, for example, if color equals 1, we can now use color equals black, and it's way more intuitive to tell what is going on in our code. That's why we use enum. You can do as many as you want. You can simply use them in here, so you can change white against black and so on, and it will simply work. So what would be standing here is then internally something like this, color equals 0, but we can simply use white and black now to represent our colors. So that's what an enum is about. The next thing you might wonder is, what is a struct? And a struct is something where you combine different information into one, not directly class, but an object which allows you to combine specific parts together. In this case, for example, we combine the name of a player with the bool value, whether or not it is an AI. You can also do something like a telephone book where you have the name, the telephone number, the address, the email address, and so on. And you can all put that into a struct. So you can use this function or this creation of an object as often as you want, and you can put as many as you want into it. It always allows you, or a struct is best used when you have some data which is reoccurring. So for example, in a telephone book, as I mentioned, you will always have a name, you will always have a telephone number, you will always have an address. So this will all be part of your telephone book, and then you can simply instantiate a telephone book by telling, okay, I want a player info in our case, and the name of the player should be Luca, for example, and I don't want him to be an AI. I also want a player who is called test, and the test should be an AI, so you simply can set that up using this struct here. All right, let's go back to console.chess.cpp. We also have something else here, which is called a map. What is the map about? In a map, you will always have a key and a value. And in our case, we can simply ask the map for their value using this key. So when we go and tell player details and we want, sometimes you use something like get key. It's not here the case, but I simply want to show you how it works. That's JavaScript, Java in this case, for example. And when you enter white here, you will get actually the player info, which consists of the name of the player and whether or not it is an AI. So you can use those two values later on to determine how you have to use this player inside your code. So for example, if it is a player, you want to provide him with, please provide your input. If it's an AI, you simply want to make it go on with the best move possible. So that's what the map does. The key in this case would be the player color and the value, the player info. And we call this the player details. All right, so let's go into the main function. The main function starts with a conversion, or actually a saving of the current time as a so-called seed for the random number generator for the weak AI. We will use that later to be able to switch between a very strong chess engine or version of Stockfish and a more weak one, which will not use always the best move possible against us, but maybe some random move. The console chess itself is our class to call the methods from. Simply use the player details and fill them up by the function getPlayerDetails. That's all part of the initialization here. You can also see we have the seed done, we have the instantiated console chess class, we have our player details located in this map here then, and we set our initial fence string, which doesn't have to be the starting fence string, it can be just any fence string you want. And then we just determine which player is currently playing. And when we find a B here, you might wonder why this is the case. I will show you in a second, but we just determine which player is currently playing based on this part inside the string here. Then we go into the game loop, which starts with the while true, and then we ask for the next move of either the player or the AI and write the result back into the fan variable. If the fan variable equals game over or exit, we break out of this while true loop and we'll end up down here where we simply close Stockfish and end the console program. All right. So what about the get player details now? That's actually a very, very long part, but it's not as hard as it seems at the beginning. So we simply instantiate some variables here, and then we start with a printout where we tell our player he should enter his name. Then we wait for his input. That's this part here. And then we determine, so you can put anything in there, no restrictions. And then we start with a while true again. And this while true is because we need a specific input. And this is whether you want to play against the AI or not. So we simply prompt the player with, do you want to play against the AI? Answer with yes or no. And then we wait for his input and write this input into the variable play against AI. If he inputs yes or no, we will break out of the while true loop and go on with the next part down here. If he provides an incorrect input, we will ask him for entering yes or no and tell him it was an invalid answer. What you can also see here is that we give the console output and then turning the color to red. Then we provide our feedback and then we turn the color back to white and end this with the \n. Why is this the case? If we don't do that, everything else, which is printed after this part here, so if we miss out on the white part here, will be printed in red. And that's not what we want. So we simply want to have this part in red. That's why we encapsulate it between this color and the normal color, so we can end up with the normal color again and then go on with the console output. All right, now we have two answers. Whether the player wants to play against the AI or not. If he enters no, we will ask for his opponent's name. He can enter everything in there. As you can see, there is no while true. And we simply get what he puts us into the line and write that into the variable opponent. Then we determine who wants to start the game. We have a while true here once again because we want a specific output. And that is, we want either the player or the opponent to start. Then we simply check again, what is the input? And if the input equals player or opponent, we can go on and set the player details of white to, I will explain that in a second, to the player who wants to start, and the black player details to the player who will be second. We also check once more whether or not it's a valid name, and if it's not a valid name, we will provide feedback to the user and tell him, sorry, it's not a valid name. Please tell us a valid name. So the player details are then filled with the starting player, and the starting player is either the player or the opponent. So if the starting player is the player, we fill the player info with the player name and we tell it's not an AI. If the starting player is not the player but the opponent, we put the opponent into the player info and thus white will be our opponent. The same for black. When the starting player is the player itself, we will put for black the exact opposite into, so black will be then the opponent. And if the starting player is actually our opponent, we will put as the black player the player in there. Sounds very complicated, but simply said, it's about whether or not the opponent should be white or we should be white. We both know that none of those players are AIs because we asked before, and thus we can simply put that into our player details. What if the user enters yes? If the user enters yes, you can see that we have another output. We simply tell him he will be playing against the AI, in our case, Stockfish. And now we prompt him for a valid skill level. What is this about? When you have an input which has to be an exact number, in our case between 0 and 20, you have always to look out for the correct input. So in our case, we start with the while true loop once more because we want a specific input. And now tell him which skill level, 0 to 20, should the game have. And now we wait for the input of our player. Then we try to convert the skill level, so the input, which he provided to us, to an integer. If this is possible, we go on down here. If not, there are two things that can happen. Either it is an invalid argument, so we don't have a number here. So we tell him, invalid input, please enter a number. And it can also be out of range. So 0 and 20, for example, he enters 30. Then we tell him input out of range, please enter a number between 0 and 20. And then we go on with continue in both cases. So we jump right back here and ask him once more, what difficulty should the game have? If the conversion works and the skill level is actually properly set, we simply check if the skill level is bigger or equal to 0 and the skill level is smaller or equal to 20. If this is the case, we have a valid input and we break the while true loop and can return the skill level afterwards. If it's not the right input, we tell the user, sorry, invalid skill level. Please enter a number between 0 and 20 and jump back to the while true loop, and we'll ask him once more to provide us a number between 0 and 20. So afterwards, we can be sure that the skill level will be an integer between 0 and 20. So what you can already see is when you want a specific input to happen, always use a while true loop. And if you don't want a specific input, you can simply just use getLine and that's it. But please always remember, it's better to check for a correct input than for not checking. For example, in JavaScript, you can get a JavaScript injection if you don't check your input correctly. And thus that can actually be very threatening towards security issues and so on. All right. So we now know how the player details work, but we haven't moved further than the skill level, which we now know will be an integer between 0 and 20. The next part will be the while true loop. So once more while true because we need a specific input and we want the player to tell us who should start, whether it's me, so the player, or the AI. We can tell that the opponent will be an AI because the player shows that he doesn't want to play, that he wants to play against an AI. And thus we can simply break if he puts me or AI into the console. If he doesn't provide anything of those two, we just tell him, please enter a valid name and tell him once more, you will play against the AI. No, sorry, who should start? Provide us me or AI to move on. Then we have the same part as in the upper part. We simply have the player details of white. If the starting player equals me, then we put the player info with player and false. Otherwise, we put the name Stockfish in there and tell that the player info for this specific player is true, so the player will be handled as an AI. Same for black. If the starting player equals me, we will then tell the opponent is Stockfish, and this is of course an AI. And if the player is not the starting player, then we will have if the AI is the starting player, we will put player and false into the player info because we know the player can't be an AI. All right, simply being said, we now have a filled up array of a player info, and this player info tells us which color is matching to which player name and whether or not this player is an AI. All right, we then return this map and we can go on. So far, so good. Let's go to the next part. And this next part is, as you can see, the get next move part. What does happen in get next move now? So, no, sorry, let's go back one time. I told you we have the player details now filled up and we can actually tell which player should be playing now. But what I haven't showed you is the static cast part. This static cast is necessary because, as I said, the enum is handled internally close to an integer, but not exactly the same. And that's why we need the static cast player color, and then we can find out whether or not B is currently the one playing. Why exactly do we need B? Because the first thing we do in get next move is that we ask for the Stockfish response and ask for the response with a specific skill level and a specific fence string. And you can see we already put the fence string into there, and the skill level is a global variable, so we already know this. And then the next option we do is that we have the current player and we simply switch the colors. So what happens in there is that we once more cast the player color from an integer to a enum, and this happens by adding 1 to the current player. So imagine we have a black player now. So we start with a black player, so the player number is 1 plus 1 would be 2, of course. And 2 modulo 0 equals 0. If you haven't heard about the modulo operator yet, the modulo operator simply cuts a number. So for example, if you have 3 and you do something like 3 modulo 2, you will always have a so-called rest operator. So it will end up with 1. So how often, it's not necessarily interesting how often the number is going into the modulo operator, but instead what is the rest once you operate through it. And that's, for example, 3 modulo 2 would be 1, 5 modulo 2 would be 1, and so on. You get the point here, I guess. And in this case, we can simply switch between 0 and 1 and always ensure that the next player will be handled. So when we find a black player inside the string, the next player will be white. If we find currently a white player in there, we have 0 plus 1 modulo 2. So this is 1 modulo 2. And 1 modulo 2 is simply 1. So we end up with the black player being the next one who is allowed to play. All right. So far to the casting. Now we have the current player name. What happens with that? We simply check the player details with the current player, which is either black or white, and ask for his name. Now we know the name of the player. And what is with the opponent name? There's a function called getOpponentName, and you can already see it's quite above here. So what do we do once more? We simply cast the enum, or the integer of the current player, to an integer, and then back to an enum, so we know the integer number of the opponent. Remember, this can either be 0 or 1, and then we cast it back to an enum and return the name using this as the key. All right. Now we go on with the chess AI and we print the Stockfish response. So what is the Stockfish response? I can simply show you by opening up console.chess.exe, and that is this program here. Now I enter my name, then we have the yes or no, which you already know. Yes, then let's go with 20, and I want to start. And you can see this is what we get printed out. And that's exactly what this print Stockfish response do. We provide the response, we provide some things he should output. And in our case, this is board, legal moves, and defense string, which looks then like this. So the board, the legal moves, and defense string, and they get simply print out for us already. That's a part of the chess AI, as you can see, and I already wrote that for you, so you don't have to worry about that. You just have to simply tell him what you exactly want from that, and then everything will work fine. So now we have some values we can extract from the response. And the response, first of all, is checked for whether or not it contains a checkmate. If we have a checkmate, we look for if the current player is an AI. If the player is an AI, our opponent has won. So in this case, the player has won. So we just simply tell him, okay, well done, you just beat Stockfish or whatever. You can be proud, not many managed to do this. If the current player is not an AI, the AI has won, and we tell him, sorry, Stockfish found a way to beat you, better luck next time. And if not, we have a win from the player against another player, and then we tell him, congratulations, you won against whoever the name is, and what a phenomenal game. And then return game over, because then the game is ended. If no checkmate is visible, then we have to check if the current player is an AI. If yes, we have to check if a draw is offerable. And in this case, we then would tell the player, well done, you achieved a draw against Stockfish, and return game over to end the game. Then we have best Stockfish against itself. So in this case, the current player name is Stockfish. Then we tell, your turn, please enter one of the legal moves shown above, and we respond with the best move, or we respond with a random move, which you can see underneath. And in this case, we never go underneath that. But if you want to, you can also put that into the brackets, and you will have a random move, which is chosen from the legal moves. And then print it out. So your turn, and then the player name, please enter one of the legal moves shown above, and we simply respond with the random move and the fence string before. So we actually can initiate a new state of Stockfish. Quite exhausting, I know. I will cover that up in a second, but that's the detailed explanation now. If not, we play AI against the player. So if the response includes a draw offerable, we have to once more check that the player is entering something correct. So first of all, while true, we say there was no pawn capture in the last 50 half moves. Do you want to offer a draw? Yes or no? And then we check for the input, and when the player wants to tell us yes, then we say, congratulations, you achieved a draw against, and return game over once more because the game has ended. If no, we simply go on, and that's it. We break out of this loop and go on with the next move. And here is the interesting part. Here is finally the section where you can enter your move. Everything else before was checking of whether we have a checkmate, we have a draw, or we have an AI player against us, and he's currently the one who can move. Now we have the move of the player. And here something interesting happens. Because we have the function getValidMove here. So what does the get valid move do? We ask for a specific move. He can choose from all of the legal moves. That's why we provide them here, as you can see. And we then ask the player to enter his turn. In this case, we can see those are the green moves down here. And we then check for the input. If the input equals exit or quit, we simply return exit and end the game. Otherwise, if the input is not exit or quit, we erase every space in front of the input and every space afterwards to just have the part which is interesting for us. And then we go on with a so-called iterator. So what is this? For the length of the legal moves, we will check if the legal move is equal to the input. So if we don't iterate towards the end, then we remove the add-on from the move, and you might wonder what's that again. It's quite a tricky structure, but since we changed something for Stockfish to be working, as I told you, we have the arrow, we have this pipe, and we have the minus in there to tell us whether we have a promotion, a castling, or a en passant. We have to remove that from the string once more so Stockfish can work with it again. And that is done in here. I explained that in the last video already, but quick recap, it's just when we find an arrow in there, we always want something like, it would look something like, let's say a2 or a7, a8, and then we promote it to a queen. Whether or not it's black, it determines if we have a lower or uppercase here, and that would be the move. So we just want the first four letters and the sixth, so 0, 1, 0, 1, 0, 1, 2, 3. Those are the four first letters. 4, 5, and the sixth one would be the Q here. So we end up with something like that, A7, A8, Q, which Stockfish is capable of using as an input once again. And for the castling, we would have something like, let's say, E1, G1. That would be just the move of the king. And then we have this pipe, and then we have H1, F1 in this case. And we simply remove everything behind the pipe and the pipe itself. So it ends up like this. And Stockfish can actually use it again as the castling input. The minus is done like this. Let's say A2, B, sorry, A4, B3, something like this. And then we have the minus, and now in this case it would be B4, which would be threatened by the en passant. And Stockfish can also not work with that, so we just remove everything behind and the minus itself. So in this case, we just end up with that, and Stockfish can use this as the input again, as you can see right here. All right, that's the quick recap. Let's go on back into our function. And we were in the get valid move, right? So that's exactly what we do here. So we iterate over it, and if we find a legal move, we make sure that Stockfish can handle it, and we remove everything we added towards it, or which I provided already for you, which I added to it to be able to distinguish between an en passant, castling, and a promotion, and a legal move. So a simple legal move would not have anything special, and Stockfish can work with that. Right. In the else part down here, so if we have the input not inside the legal moves, we return, okay, we have an invalid move here. Please try again and provide once more the check if your turn, player data, and the name of the player. Please enter one of the green moves. So in this case, for example, B2, B3, I know for sure that B1, B2 is not working, and you will see invalid move will be printed down here. And I can't move on unless I provide something which is actually working. Let's go with A1, A3, and you can see now Stockfish made its turn, and we are once again the one who can present our turn here. All right. So now we already checked the get valid move part. And the last part we have to look at is once more in the get next move. If the move equals exit or quit, then we simply return exit and the game is over. If not, we return our move by appending moves and our move to the fence string. Okay. I think that is quite hard to understand, but let's make it a little bit clearer when I open a window once again. So I told you about the game start. That's what I'm currently doing. I click on the console chess.exe. Now the first prompt comes over where I can enter everything. You can see that is working and that's my name now. Let's choose yes as play against the AI. We get prompted with you will play against the AI Stockfish and now which skill level we want to choose. And I told you it can only be between 0 and 20. So let's enter 30 and you can see invalid skill level, please enter a number. Let's enter -1, not working. Let's enter something like this. Okay, on skill level 0. So in this case, we can enter 0.12 and it will end up with 0. All right, and now we can enter who should start, me or the AI. And I can simply put something in there and it won't work because I haven't entered a valid name. If I put something like this in there, it will also not work because it's not the exact case. So in this case, we have to enter, for example, me, or in this case, AI. And now you can see Stockfish makes its first turn and we get then prompted with what we want to do. And you can also see my name was taken exactly as I provided it. So it doesn't make any sense, but this is how it looks now. If we do the same for, all right, our console chess, but this time entering Luca, and now you will see we can enter an opponent's name, and that will look something like this. We can enter anything in there, and now we are asked who should start, and I'm not going to type this long name into there, so I want to start. And that's exactly what we just built. So we now know that the player Luca is the white player and wants to start. This player is the black player, and yeah, I don't know, I won't pronounce his name or something like this, but that's actually what we did within the get player details part. I guess that gets way clearer now, but you can see it's quite tricky to actually make sure that nothing wrong gets inputted into there and that you always end up with the right part. So here, for example, we can go with E1, G1 and it won't work because we don't have the move in our legal moves. And this is exactly how we can make this game to be played. You might wonder now, how can I make the AI play against itself? And that's very simple. Let's do this to end this section. And I simply have to put something into there. Let's put into there true. Play against the AI, no. Okay, that's wrong. Go on further here. And now we tell the player and true. And we tell player and true. And that should be it already. And now you can see I can still enter the same parts. So Luca, let's go with yes. I'm playing against Stockfish, let's go with 20. And I want to start. And you can see the AI is playing against itself now. And this is how we can check whether or not our end parts are working. And in this case, you can see Stockfish beat me. And since I handled him as a normal player, it actually tells me you can be proud to beat Luca. I'm a total noob at chess, but still. Uh, and yeah, this is the output we just wanted. So we can also add something like the random stockfish into there, and we can simply tell, for example, let's go with that. Now we have a good playing stockfish against worse playing stockfish. Sorry, I'm just used to using Python. So now once more. And when we do this, and we enter, we want to play against the AI. We will simply have, do we want to play against the AI? Yes. And I want to play on level extreme, and I want to start. You can see it works the same, but now we have random Stockfish against Stockfish, and now you can see we have Stockfish playing against random Stockfish, and of course Stockfish won because he's way better than the random Stockfish. All right, let's uncomment that once more and put that back to false because the player is no AI for us. But that's simply how you can implement that. And if you want to play as a player against the weak Stockfish now, you can either implement something like this as the other color, or you can simply just here exactly write. Let's do it like this. I guess that's the easiest way. Let's comment that out very quickly. So we end up with this part. And now when we enter that into there, we are playing against the Stockfish that doesn't use its best move, but its random move. And you will also see that, sorry, that's wrong. I have to put into, yes, I want to play against the AI. So in this case, Luca, yes, 20, me. And now we start, and now I just put something like B2, B3. And you will still see that its name is Stockfish, but it's not using the best move against you anymore, but a random move from all of those possible down here. All right, that's it for the code. And now you can actually play around, have some fun with it. And I wish you a lot of fun with that. And let's just move on to the end of the lecture, and then we're finished for today. All right, what can I say? You made it to the end of the Plain C++ lectures. I'm already looking forward to head further into Unreal Engine with you. I hope you had some fun. You know I did. And I already highly, highly appreciate moving over to Unreal Engine because I also think the console programs are quite boring. So, with that being said, let's see you in Unreal Engine. Have a good day and see you soon.